The Snowy River is a major river in southeastern Australia. It originates on the slopes of Mount Kosciuszko, Australia's highest mainland peak, draining the eastern slopes of the Snowy Mountains in New South Wales, before flowing through the Alpine National Park and the Snowy River National Park in Victoria and emptying into Bass Strait. While the river's course and surroundings have remained almost entirely unchanged, the majority of it being protected by the Snowy River National Park, its flow was drastically reduced in the mid-20th century, to less than 1%, after the construction of 4 large dams and many smaller diversion structures in its headwaters in New South Wales. As part of the Snowy Mountains scheme, the river has been immortalized in cultural folklore through the poem The Man from Snowy River, written by Banjo Paterson in 1890, which formed the basis of many subsequent works in film, TV and music theatre. Geography. The main headwaters of the Snowy River, which include the Jindabyne, Gungahlin and Thredbo rivers and many smaller alpine watercourses, are predominantly located in Kosciuszko National Park in Meet near Jindabyne. From this point the river winds 352 kilometers southwards through inaccessible country, comprising private lands and the Snowy River National Park, eventually reaching the sea in the Snowy Inlet, at Marlow, near Orbost, Victoria. In New South Wales, the river runs through the Snowy River Shire. The tributaries of the Snowy River below Jindabyne include the Murwamba, Woolwye Creek, McLaughlin, Delegate, Jacobs, Pinch, Sugan Bugan, Dedek, Buchan, Roger and Brodribb rivers. In 1986, Jennings and Mabbott mapped 4 geomorphic classes in the Snowy River Basin: Australian Alps, the Monaro Tablelands, the East Victorian Uplands, and the Gippsland Plains. Each class is physically distinct from one another. Rainfall. The general distribution of rainfall over the Snowy River catchment is controlled by orographic effects. There is a strong rainfall gradient across the catchment. The highest average annual rainfall is recorded in the higher alpine reaches of the Snowy catchment, with 1,800 mm recorded in areas above 1,500 meters. The lowest average rainfall is recorded in the rain-shadow-affected northeastern catchment on the Monaro Plains around Dalgety, with average rain below 500 mm. The lower eastern sub-catchments are more strongly influenced by coastal rainfall patterns. For example, peak rainfall in the Delegate catchment is strongly influenced by east coast lows, rather than the alpine-dominated precipitation patterns in the upper Snowy River catchment. These local variations in rainfall result in distinctly different hydrology in the rivers across the Snowy River catchment. Hydrology. The snow melt-derived rivers in the Snowy Mountains typically have the lowest average stream flow in the months from November to June, with October having the largest monthly flows of the year, e.g., mean monthly flow for October at Dalgety was 283,973 megalitres prior to the snowy scheme. The large flows in September and October are derived from snow melt, and hydrologically it's one of the key aspects that defines these mountain waterways. Typically, Australian rivers can be defined as having highly variable river flows, with frequent zero flows even in humid areas due to the extreme age of soils and consequent extremely high water absorption to absorb minimal phosphorus via proteoid and similar root types. The mixed snow melt rainfall rivers of the Snowy Mountains can be defined by strong seasonal patterns and remain permanent throughout the year, with no record of zero flow ever observed in the lower Snowy. Prolonged base flows over the summer months are another feature of these types of rivers, driven by snow melt-derived groundwater. In the lower reaches of the Snowy River catchment, the larger tributaries have a distinctly different flow regime to the snow melt rivers of the Alps. These tributaries are typically dominated by the winter rainfall and often have peak monthly flows a few months earlier than the snow melt tributaries. The peak monthly flows for these lower snowy river tributaries occur in June through July. Additionally, the flow regime in the lower tributaries is far more variable and unpredictable. Waterfalls. The Snowy River below Jindabyne Dam contains 4 major waterfalls: Stonebridge Falls, Corrawong Falls, Snowy Falls and Pinch Falls. Potentially, many of these waterfalls act as barriers for the large-scale movement of aquatic species in the main stem of the Snowy River. The flows required to drown out the largest barrier, Snowy Falls, is potentially larger than the environmental water releases to the river via Jindabyne Dam. Parklands and protected areas. Around 70 to 80% of the Snowy River's length is protected by national parks. These include, from upstream to downstream, Kosciuszko National Park, New South Wales; Alpine National Park, Victoria; Snowy River National Park, Victoria. River ecology. The aquatic flora and fauna of the Snowy Mountains snowmelt rivers have evolved with the predictable seasonal hydrological snowmelt peaks and constant summer base flow conditions. Many of these flora and fauna are cold water specialists. River habitat. The in-stream habitat of the Snowy River below Jindabyne can be best described as highly disturbed. Many of the in-stream features of a large upland river are not evident today. The substrate was previously typified by a clean cobblestone substrate. Today, the river channel has contracted and the substrate has a heavy cover of sediment, overlaying much of the cobblestone riverbed. The bushfires of 2002-03 added to this problem as large amounts of sediment and organic matter were deposited in the river via tributary inflows. This input of sediment led to the substrate becoming finer. This pattern of increased silt in the pools of rivers and streams has been observed across the Snowy Mountains following the bushfires. These bushfires are likely to have a long-lasting influence on these waterways. Larger events are required to start to improve the condition of the riverbed. Events of 1,000 megaliters per day will start to move the unconsolidated fine particles of the riverbed. Events between 1,000 and 3,000 megaliters per day are important for conditioning the riffle habitats. The current poor condition of the riverbed is one of the key factors inhibiting the aquatic fauna typical in a snowmelt river. Water quality. The mountain streams and rivers are typically low in nutrients and electrical conductivity. Electrical conductivity is generally below 50 microsiemens per centimeter. Large dams can essentially influence downstream water quality via 2 key mechanisms: either by poor water quality released from the waters of the dam itself and reduced mixing of the river water column attributable to lower water velocities leading to anoxic conditions at the bottom of deep river pools. Influence of Jindabyne Dam on water quality. Possibly the main influence on downstream water quality from Jindabyne Dam is the influence on water temperature. Unlike many other dams where cold water pollution is a concern, where water is released from below the thermocline in the reservoir, the water is released from the surface waters of Lake Jindabyne. The water temperature of the Snowy River downstream can reach temperatures of 59 degrees Celsius in summer. The Snowy River is on average 4 degrees Celsius warmer than the surrounding and regulated snowmelt rivers, with a peak difference of up to 8 degrees Celsius. The water temperature in spring appears to be greatly warmer than the surrounding snowmelt rivers. Flow and thermal stratification in the Snowy. Thermal stratification in the river reaches below Jindabyne is typically restricted to a few of the larger or deeper pools. In general, thermal stratification is spatially restricted to the pools that are typically greater than 4 to 5 meters deep. Pools shallower than 4 meters have not displayed any thermal stratification. Stratification can occur between October and March, but typically does not persist for very long in the Snowy River and the Jindabyne Gorge. Breakdown of thermal stratification is frequently driven by the cooling overnight air temperature. This region experiences a very large temperature range between day and night. Algae is present in the water column and on the bed of the Snowy River. The water column algae is called phytoplankton, whereas the riverbed algae is defined as periphyton. Riverbed algae. Much of the bed of the Snowy River below Jindabyne contains high levels of attached algae. These taxa are typically filamentous algae. In the Snowy Mountains rivers unaffected by water diversions, large stands of filamentous algae are uncommon. Water column algae. During 2008-9, the river pools of Jindabyne Gorge and the Dalgety uplands were typically dominated by blue-green algae. Two blue-green algae, Aphanutheca spp. And Aphanocaspora spp. comprise about 25% of the total abundance. However, these abundances are still under the guidelines and it's unclear if this is solely related to river regulation, but also reflects other catchment inputs. The composition of algae in the free-flowing snow-melt rivers are typically defined by diatoms. Over 58% of taxa are diatoms, with Fragillaria spp. Being the most numerically abundant taxa. Water bugs. The water bugs in the Snowy River differ from the bugs of the snow-melt rivers. Dams have been shown to have an adverse impact on the water bugs of rivers. Cynid mayflies and oligochaete worms are generally typical of the upland-regulated Snowy River. Other studies have also found greater densities of Cynidae mayflies in regulated rivers compared to in regulated rivers. Reduced high flows and constant low flows in the upper Snowy River are likely to have favored high densities of worms through the buildup of silt and organic matter in the pools. Nichols al. and Petz al. also found greater densities of segmented worms associated with soft sediments and coarse organic debris in response to river regulation. Chironomids were also numerically dominant in rifles sampled in the regulated Snowy River. This response has been found in many other studies of regulated rivers and has been attributed to an increase of periphytic growth in riffles that increased overall habitat area and food availability. Conosucidae caddisflies, larval and adult elimids and Onychogastridae distinguish the snow-melt rivers from regulated Snowy River. Marchant and Heher reported that AUSRIVAS models predicted Conosucidae and elmids to be present in the upper Snowy River, but these taxa were not found in their study. The greater density of these taxa in snow-melt rivers compared to the Snowy River is consistent with river regulation. Marchant and Heher attribute the absence of these taxa to dams acting as a barrier to drift and limiting recolonization of these taxa and not to flow regulation. The upper Snowy River sites are all below the confluence of the Mwamba River, which provides a pathway for recolonization of the Snowy River. Therefore, the reduced flow and altered flow regime is likely to be the primary cause of reduced densities of these taxa in the upper Snowy River rather than the barrier effects of Jindabyne Dam. There is little information on the responses of Onychogastridae to reduced flows and altered flow regimes, but it is probable that an elevated temperature regime combined with lack of suitable sandy edge habitat has reduced their densities in the Snowy River. Fish. The fish assemblage of the Snowy River below Jindabyne are clearly divided into two components. This division is based on that which occurred in the upper catchment and that in the lower catchment. The major differences between the two zones were the low abundance or absence of diadromous migratory fish and the greater abundance of short-finned eland trout in the upper catchment, and the greater abundance of Australian smelt, Congolian long-finned eel below Snowy Falls. These upper and lower Snowy River zone differences were greater than the differences between unregulated tributary streams and the highly regulated main channel of the Snowy River within either zone. In the upper catchment, river blackfish, brown trout and short-finned eel were more abundant in unregulated tributaries, whilst long-finned eel and goldfish were more abundant in the regulated upper part of the Snowy River. In the lower zone, eastern Gambusha, long-finned eel, Australian smelt, short-finned eel and Congolese were all more abundant in Snowy River, while common galaxias and short-headed lamprey were more abundant at tributaries. flow thresholds below Jindabyne River. Scientists are currently undertaking studies to determine the flow thresholds for a range of riverine processes. Some preliminary flow thresholds that have been developed include: further defining of ecological flow thresholds is currently in progress via modeling, field-based studies, and flow trials. See snowy flow response monitoring and modeling.